So good morning everyone. So our today's Leetcode question is 868, that is binary gap. So in this question we are given an integer n, and we have to find the longest distance between any two adjacent ones in the binary representation of n. And if there are no adjacent ones, then we have to return 0. So suppose here we are given the binary representation as 1001. So if you'll see there are two ones, so the gap between these two ones is 3. So this is the answer. So if you'll see the examples, so first number we are given is 22. So the binary representation of 22 is 10110. So the gap between these two ones is 1, and the gap between these two ones is 2. So the answer is maximum one, that is 2. Then we have 8. In 8 we have only 1. So there are no two adjacent ones. So in that case we have to return the answer as 0. Next we have 5. So 5 is represented as 101, and the gap between these two ones is 2. So the answer is 2. If you see the constraints, so our n can be up to 10 ki power 9. So how many bits will it require? So it will require log 10 ki power 9 to the base 2. So if you solve this, it will be log 10 ki power 9 base 2 upon log 2 to the base 2. So if you solve this is 10 and 0.30. So it will approximately require 30 bits, right? So let's see the approach. So the approach one is, what we can do is we can scan the whole number bit by bit and then track the positions. So we get, what we can do is we can scan from lowest significant bit to most significant bit and then track position of the previous one. And when we see a new one, we'll find the gap using current position minus the previous position, right? So let's see the example. So in example we have taken number is equal to 22. So the binary representation of 22 is 101100 So what are the possible cases? N and 1, it will give us, if 1 means the current bit is 1, else the current bit is 0. So if the current bit is 1, what we'll do is we will check whether there is some last one present or not. So if last one is present, then we update the answer by current position minus previous position. Else what we do is we just update the previous by current position. And if it is 0, then we won't be updating the answer. In that case, we directly, what we are doing is we just right shift the number and increase the position by 1. So these are the things that we'll do. So let's see here. First we check whether the current bit is 1 or 0. So current bit is 0, so we just right shift the number and increase the position by 1. So our position has become 1 and the number has reduced to 1011. Then again we check the first bit. So here last is -1, means there was no one present before this one. So we just store this position in previous. So our previous way has been updated to 1, and then again we right shifted and increase the position to 2. Again we do the same thing, checked. So now last is not equal to -1. So what we do is we'll be taking the answer, updating the answer. So answer can be either the maximum of the previous answer or the current answer. Current answer is position of the current one minus the position of the previous one. So we have updated our answer. So now our previous has also been updated to index number 2, and our current position is 3, but at 3 we have 0. So we won't be doing anything, we just be right shifting the number and increase the position. So now here n and 1 is equal to 1 and last is also not equal to -1. So we'll be updating answer by maximum of current previous answer and the current answer, that is 4 minus 2 is 2. So we get our answer as 2. So now if you notice the number has become 0, so we'll be stopping and we'll be returning the answer as 2. So if you'll see the code part, so we have taken last is equal to -1. This will store the position of previous one, and this will store the current index of the number, and it will store the answer. And we are using a loop until our number is greater than 0, and then we are checking whether the current bit is 1. So if the current bit is 1, and last is not equal to -1, means some 1 was present earlier, then we will be updating our answer, and then we will be updating the position of the previous one. And if this is not there, or in normal case also, we'll be right shifting the number by 1 and increase the position, and at the end we'll be returning the answer. There are some other approaches that we can also do. The first one is like we can store the this number in a string, means the binary representation in string, and then find the gaps in that string between the ones. The second approach is we can jump directly to the position of 1, but the thing is that how to find the index or position of this one, like what is the position. So this one is difficult, else this approach could have been faster than the current approach, but finding index will take we have to scan all the previous bits. So in worst case it will be big of 32 for like every bit, so that's why it's slower. Third approach is like store the indexes of all ones, like suppose first one is at 3, then second is at 3, then third is 7, so and then find the gap difference between the adjacent ones, and then return the maximum one. So you can try out these approaches also. So I hope you like the solution, so please make sure to like, share and subscribe the channel.